Einstein's work on the laws of physics took a groundbreaking turn in 1905 when he proposed his general theory of relativity, and the discovery has dominated the world of classical physics ever since. Its benefits can be seen everywhere, from space missions to GPS systems, so let's talk about what his theory actually entails. In 1905, Einstein proved that the laws of physics are the same for all non-accelerating observers, or these laws are the same in all inertial frames of reference. Why? This is because there's no fixed frame of reference in the universe. Everything moves relative to everything else. B. The speed of light in a vacuum, known as c equals 3 times 10 to the power of 8 meters per second, is independent of the motion of all observers, making this value constant and absolute in all scenarios. Adding up these two statements tells us that the speed of light in a vacuum is the same in all frames of reference. A fraction of Einstein's theory of relativity concludes that time does not pass at the same rate for everyone. A fast-moving observer measures time passing more slowly than a relatively stationary observer would. This is called time dilation and can be represented by this equation and the following graph. We can see here that at speeds which are low, there's a small change in time dilation, but at speeds which exceed 75% of the speed of light, the increase in time dilation looks drastic. At 0%, there is no time dilation, and it is realistically impossible to achieve 100%. A more thorough analysis can go to show that time slows down relative to a stationary observer. Let's talk about how mass and energy are simply different manifestations of the same concept. This can be shown using Einstein's famous equation, E equals mc squared. As a result of E equals mc squared, an object accelerating with a strong velocity might appear to have increased mass relative to a slow-moving one. Since mass equals energy, this is due to the fact that increasing an object's velocity also increases its kinetic energy and hence its mass. This is how nuclear explosions happen. Some conclusions: matter cannot travel faster than light. Mass increases with the velocity until it reaches infinite. This is when c is achieved. And as an infinite mass would require infinite energy to move, which is theoretically impossible.